How do we build an AI model that intuitively recognizes the importance of time in recognizing things? This is the problem that Jeffrey Ellman solved in 1990 with the recurrent neural network. What Ellman recognized is that there are many processes like speech or the way humans read text, which need to be understood in a sequential and therefore temporal way. He argued that if you just represent time as a spatial dimension and like a shape, like a waveform, it's not gonna be nearly as good for recognizing speech as if you recognize speech as a fundamentally temporal process. And so he built this model to recognize things in the light of how they're ordered temporally. So this builds on the multilayer perceptron, which I talked about in the previous video. If you haven't watched it yet, check it out, because it does provide important context for how this works. So right here, we basically have a pretty standard multilayer perceptron. And this is the part that Ellman adds, which is where you get recursive from. And so he calls it context in his paper. And what you do basically is you have the input, you feed it to the hidden layer or hidden layers. You can always add more hidden layers, and then that goes to the output. And so far, it's kind of like a standard multi-layer perceptron. But what he adds, which is the recursive part, is you can pass either the output layer or a hidden layer back to become the context for the next input. So he provides both methods. It really depends on choice, which one you use. That's why I said or here. So you can use either the hidden layer or the output as context. So then in the next iteration, when you give a new input, both the input and the context get fed into the hidden layer to produce the next output. Or if you're feeding the hidden layer in this context, you might have an output maybe every 4 times or every time. It's really up to you. So that's how the recurrent neural network works. And after explaining how this works, Ellman showed 5 different things this is good at. And his instances were always about predicting the next element of a sequence. You can do other problems though as well. You can do speech recognition. And he talks about how that can emerge from predicting the next element or token or binary or whatever. So we showed this model can solve the XOR problem. It recognizes letters from binary sequences, so you just feed it the binary sequences which represent letters, and it will figure out which binary sequences correspond to which letter, essentially. And it can figure out which letters come together to form words. It can figure out types of words, like it can figure out the difference between a noun and a verb and a masculine and feminine, and things like that, which are essential for sentence structure and where words occur in sentences. And so figure out sentence structure. So it can also figure out these are all related, but various levels of complexity. And so it can figure out sentence structure. And it can use sentence structure to figure out things like which words tend to be used together and therefore which words are related to each other. Because if the word man and woman often occur with sentences that are otherwise identical, it proves that they're related. And if man is more likely to occur with boy and woman is more likely to occur with girl, things like that, it can even figure out things like man and boy are masculine, woman and girl are feminine, and many other such things. Like can figure out for sure like word order, like nouns, verbs, how they occur in sentences. So this is the recurrent neural network discovered by Ellman, and it's used a little bit today, but it was mainly in many ways it could be replaced by the convolutional neural network, which I will explain in the next video, which was invented 8 years later in 1998. So I will be releasing that video shortly in the next few days. So stay tuned for that. And if you haven't already, please look up my other videos and like and subscribe if you want to see more of my content.